Hi everybody, this is Gigi from Kauai Community College. In the last video, we talked about region between curves, and we have talked about the vertical strips, right? And then we have talked about the horizontal strips. Now we are going to go into specific examples, okay? So suppose you have the functions y equals 2x plus 4, that's a line. So let me just draw that, 2x plus 4. Y-intercept is 4, so 1, 2, 3, 4. Okay, and the slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, and or down 2, left 1, down 2, left 1, and we have this particular line right here. Okay, so that's the line that we have right there for the first function, and that is y equals 2x plus 4. Okay, I need to learn how to draw lines a little bit better. Anyhow, that's the red. And then we have, I'm going to say use black here. That's x squared plus 1. X squared plus 1 is a parabola, right? So getting shifted up 1. So the vertex will be right here. And that's a normal parabola. So over 1 up 1, over 2 up 1, 2, 3, 4. And over 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, what do you see? An intersection right there on that side, right? And then on the other side, we would say over 1, up 1. Oh, look at that. There's another intersection right there on that side. Oops, that's a really bad drawing. I was trying to not plot points. But let's see, here it is. Okay. So which region are we talking about? And will we want to use a vertical strip or a horizontal strip? Okay. So we are looking at the region in between these two curves, and it looks like we have vertical strips here. Okay, and that will be like that, right? And we are talking about this intersection right here at -1 and at 3. So that was your A and your B from the previous video, right? Now, if you want to really know for sure when the picture isn't real nice, how do you find the intersection between two curves? Well, the same way as how you would go ahead and set the y equals to each other. So then you would have x squared plus 1 is equal to 2x plus 4. X squared is minus 2x minus 3 equals 4. Factor, you have x minus 3, x plus 1 equals 4. Therefore, x is equal to 3 or -1, which are those two intersection points right here and right here. Okay, and those would be the limit of our integral when we are setting them up. Okay, now let's take a look at the horizontal vertical strips of one of those rectangles. So one of those rectangles will look like this, right? And we are doing a vertical strip, so we are talking about dx, or say delta x as our the base, right? The base is delta x, or we would say with respect to x when we are setting up our integral. And the height would be red minus black. Okay, so red minus black And that would be this right here minus this right here. So that would be 2x plus 4 minus x squared plus 1. Okay, and reduce, that would be x squared negative x squared, right? Negative x squared plus 2x. 4 minus 1 is 3. Okay, so that is the height of that rectangle, right? So let's go ahead and find the area of one of those strips. So the area of one of those strips would be length base times height, right? Base times height in this case would be negative x squared plus 2x plus 3 multiplied by delta x, right? And remember, what are we going to do? We're going to add them up, right? Like this. And we are going from 1 to n, and then 1 to n of negative x squared plus 2x plus 3 times delta x. And what are we going to do with that? We're going to take the limit as n goes to infinity, meaning make it so many rectangles, right? Let n be really big so that my rectangular strips are even going to be thinner and thinner and thinner. So you have many rectangular strips in there, and that would get you even a better and better estimate of the area of that shape, right? So, and when we do take the integral of that, that turns into take the limit as n go to infinity, that turns into what we define as an integral, right? So we're talking about the integral from negative 1 to 3 being the total area of the function negative x squared plus 2x plus 3, and we are integrating that with respect to x. And I hope you know how to do antiderivatives from here on. So that would be x to the third, the exponent goes up, right? And divide by 3, that's negative 1/3 x to the third plus x squared divided by 2. 2 divided by 2 is 1 plus 3x. And we are evaluating that. Remember, if it was just an antiderivative, you have a c, right? But we are evaluating it from negative 1 to 3. So in other words, the f of 3 minus f of negative 1, so that the c will basically be gone, right? So when you plug in the 3 and the negative 1 and you subtract, you should get the total area of this shape being negative 1/3 times x. Well, I didn't mean to say x, I really mean to say 3, because we're going to plug 3 into that, to the third power plus 3 squared plus 3 times 3, and you are subtracting this portion being negative 1/3 times negative 1 square, not square, cube, plus negative 1 square plus 3 times negative 1. And you would go ahead and do the calculation. And when you think about the calculations, you have this is 9 minus this whole thing is 1, and minus, so that would be plus 1 2/3. So that is 10 2/3. That's the area of that odd looking shape right there. Okay.